Hello and welcome to this video for OCR GCSE, the development topic, which is paper 1, and it's about Piaget's theory of cognitive development. So according to Piaget, children's thinking changes over time, and that's based on biological age. So therefore cognitive development is a natural or an innate process. It's not something that's learned. It's something that's based on their nature, so their biological age. That's what takes them from one stage to the next stage. And he suggests there are 4 of these stages of development, and because they are related to biology, they are fixed, they are invariant. So this is the idea that they do not change. So if a child is 3, for example, they will be in the pre-operational stage. They are fixed based on age. They also go in a fixed order, so it's always stage 1, 2, 3, 4. You couldn't, for example, go to stage 1, 2, 3, back to 2, all the way to 4. They are fixed and invariant stages. And then the last word there, they are also universal. So by this he means they apply to every single child all over the world. So he obviously doesn't think that culture impacts the development of a child's thinking, their cognitions. It's just purely due to this biological process. So then these stages are the sensory motor stage, which runs from the child being 0 to 2 years old. So in this stage, children learn via their senses and movement. So senses, taste, touch, smell, it's why it's so important, isn't it, when you give a child an object, that it's safe, and if they put it in their mouth, because they probably will, small parts won't fall off, because they're learning via their senses, and movement, so crawling around, eventually walking around, moving and exploring their environment. During this stage, they develop an important skill, so it's called object permanence. And this usually develops about 12 months to 18 months old. They don't have it at the very start. And this means that they understand that an object exists, even if it's out of sight. And you might remember from the videos we've watched, so Piaget would test this by having a child play with a toy, for example, and then hiding this toy. If the child searched for the toy, then obviously they understand that it exists even though they can't see it. If a child doesn't search for the toy, then it ceases to exist for them. Then moving on, we've got the pre-operational stage, and this is from 2 to 7. Here children learn via play, via symbolism and via imagination. So a lot of imaginative play goes on at this stage, and that's really beneficial for their learning because that's in line with their cognitive stage. They also show a skill called animism. So this is when they give inanimate objects thoughts or feelings. So this could be a toy like their teddy bear, maybe saying that Teddy's hurt or Teddy's sad or wanting Teddy to come to dinner. So they're giving this object feelings. They are also able to conserve, and they will think that if one property changes, then all of the properties have. So we know those classic studies that there is another obviously video on, conservation of, for example, number. So they think that if one row is elongated, then that must mean there's also more counters in there. So they can't conserve and understand the properties of an object. They're also egocentric, and that means that they could only see from their own perspective. So they might find it more difficult to understand why somebody else is upset, or to understand perhaps the concept of sharing their toys, because they're very much about their own sense of the world and their own perspective. Moving on, we've got the concrete operational stage, 7 to 11. So children here become much more logical thinkers. They're much more able to follow kind of a train of logical thought. They still, however, do need concrete objects, and that means physical objects to learn. So we may well have children count on their fingers, as I still do. We may have children having to have blocks to do division in maths. They still need those concrete physical objects. They have also now decentered, so they can see from people's perspective, other people's perspectives, and they can also conserve. Remember, so now that means they understand the properties of an object, and maybe one has changed, but maybe another has still stayed the same. And to do this, what a skill that's helped them with conservation is the idea of reversibility. So they've also gained this skill, so meaning they can think backwards. If you think to the video of the girl with the conservation of volume, which is the one with the 2 glasses and the liquid, she remembers, so when the liquid's been poured into the tall, thin glass, you see her kind of think backwards, and she says to herself, well, all of this liquid was originally in that short, thicker glass, so therefore it must still be the same. So you saw her thinking backwards and thinking, well, if I poured this water back into the short, fat glass, it would still be the same, so it's the same amount. It's that reversibility skill. And then the last stage is called the formal operational stage, and here children can now think in hypothetical ways, so they can handle things like debates and conflicting ideas. You could maybe ask them to think, hypothetically, if you did agree with this, what might you say? And they can also think in more abstract ways, so they can do things like algebra, for example, at this point. Piaget also saw children, so across these stages, as little scientists. So that means that they actively learn by observing and interacting with the world around them. He almost said they carry out their experiments and learn via trial and error, and this therefore allows them to build up their thinking of the world. And we'll come back to that when we talk about applications. There's a little bit more for Piaget before we do go on to evaluation. So Piaget also talks about the processes that allow our thinking to develop, so our cognitions to develop. So Piaget talks about schemas. So schemas are basically mental building blocks which group similar or related information together. It's why a game like word association works. So if you have a schema, for example, for a cat, there'll be certain things that have come to mind there when I've said cat. It might be your cat's name, it might be the colours of cats, it might be meow, it might be 4 legs and a tail. There are certain things that are grouped together, and this gives us this idea that our thoughts aren't just randomly dumped within the brain, they are organised into these things called schemas. We then do have operations, so that's where schemas are linked together. So maybe your cat schema links to your dog schema, etc. And that's just a more sophisticated map of what goes on with our thinking. Now, as children develop cognitively, they're continually adding information to their schemas. This is called assimilation. So assimilation is where we come across a new piece of information, but it fits with our existing schema, and we would add that. So maybe we grow up and we have a cat, our cat's black and white, our neighbour's cat's black, and then we see another black and white cat, we can add that to our schema. So we're assimilating this information to our schema. However, sometimes we come across a brand new situation, so something that we've never experienced before, and this leads to a state of disequilibrium. In this case, the thing that we've come across, it doesn't fit with any of our schemas that we've already created. So here we have to do what we call accommodate, and that means to make a brand new schema to then fit this information in. And then obviously we can assimilate from there until we come to another state of disequilibrium, a new situation that we haven't come across, and create another schema. Okay, so schemas, those basic building blocks of information. And then assimilation, we just add to a schema, a fairly small change, and accommodation, we create a brand new schema, so a much bigger change. So if we come on to evaluation, so it's our usual sorts of points here, it's useful. So it's useful because obviously if children are all the same age and at the same stage of cognitive development, that's how they're organised in education, aren't they? So the same ages are all grouped together. Then teachers can use the idea of readiness in education. So this means that you would teach in a way that aligns with the child's age. So if I had a concrete operational child in front of me, I would ensure that I had concrete objects to allow them to learn. I wouldn't do anything like introduce algebra until they were 11 plus. We can also use discovery learning, meaning providing them the tools to learn, but remember, because they're these little scientists, we're going to allow them to learn independently and learn via their mistakes. It's also validated by research evidence. So Piaget's study into conservation of number, and he showed, didn't he, in that children in the pre-operational stage said that the elongated row had more counters, but the concrete operational stage correctly said there were the same amount of counters. Therefore, this is showing the cognitive skill of conservation is gained in that concrete operational stage, and that's what the theory suggests. It is, however, very reductionist, very, very reductionist, and this is one that you have to be able to link to it. It's named in the spec. So it reduces something as complex as cognitive development to only an innate biological skill based on age, nature. This ignores nurture and that many things might affect how a children's thinking develops, like the quality of education, interaction with parents, life events, and it even ignores elements of nature, so things like genetics. It doesn't talk about that at all. It's all about age, that's it. It also ignores individual differences, so children who have skills that are beyond their stage or lack the skills that their stage should have. So his stages are far too rigid. And then also he argues that his stages are universal. However, his original research was only carried out on Swiss children, so children from Switzerland. And then later applications, they've remained in very westernised countries, things like the UK and America. Therefore, how can we conclude the stages apply to all children all around the world when the research is so westernised? Okay guys, so now let's have a look at some exam style questions. So the first one, identify the first stage of cognitive development according to Piaget's theory. So is it A, concrete operational, B, formal operational, C, pre-operational, or D, sensory motor? Okay, so hopefully you're okay there. We're going for D, sensory motor. Next, identify which one of the following features of cognitive development is in place before the concrete operational stage. So A, conservation, B, decentration, same as decentering, C, object permanence, or D, reversibility. Okay, so hopefully you're okay there, going for C, object permanence. All of the rest occur during the concrete operational stage, don't they? So not before. Next, identify the process children go through to create a new schema according to Piaget. So A, accommodation, B, active learning, that's just another phrase for discovery learning, C, animism, or D, assimilation. So hopefully you're okay there. A, accommodation is when they create a new one. Maybe you got confused with assimilation, which is where they add information to an existing, so it's different that. Then we've got a short source, so I'll read it to you. So a teacher is working with a group of children aged 7 to 11 years. She notices that they have developed several skills. For example, Abby can focus on more than one aspect of a situation, and Marco can place things in rank order. Lucinda now understands that although an appearance of something changes, the quantity does not. The teacher believes this is because of the stage of cognitive development they are in. So the first question, identify the stage of cognitive development the children are in according to Piaget's theory. So you should go for concrete operational, both based on the child's age, 7 to 11, but also those skills that they are showing. Next, identify the child that is showing the ability to conserve. So we have Lucinda, because she now understands that although objects' appearance changes, the quantity does not. So that's conservation, isn't it? And then lastly, outline how Piaget's ideas have been applied to education. So you need to be a bit careful here because it does say ideas, so we're going to need multiple rather than just one idea. So the first idea you can talk about is this idea of grouping children based on the age that they are, and then designing our curriculum around what they're able to do. So this is called key stages. The second idea you can talk about, which is very much linked, is readiness. So talking about how you're going to teach them in a lesson. And then the third idea, discovery learning. So Piaget's idea that children develop cognitively based on age has been applied to education via the use of key stages. This is when children are grouped based on age and the curriculum taught aligns with the type of thinking a child in that stage can do, e.g. not introducing algebra until key stage 3 when the child's 11. This concept of readiness can also be applied in lesson by teaching in a way that aligns with the child's stage, like teaching children the pre-operational stage via play and imagination. Lastly, Piaget said that we can use discovery learning or active learning. This is where the child is given the tools to learn by the teacher, but allowed to learn independently by exploring the tasks themselves. Okay, thank you very much for listening, guys. As always, any questions, get in touch.